Okay, hello, this is Max. We're working on discussion 8, spring 2015, CS61A. And this question is asking us to build a binary tree data structure using just schemes. This is an abstract data type. And first, let's think about what this actually is saying. So we're defining a tree, we're going to say define make binary tree. It's got an entry and then a left branch and a right branch, sort of what we're used to. And the way we're building it is we're consing an entry with a list or a pair that has a left branch and a right branch. Okay. So how is this going to look? So a tree structure is going to have the first pair, right? We're going to have entry. And then it's cons, so this is going to be our cutter. Our cutter is going to point to another pair that in theory is going to have a left branch and a right branch, which should either point to trees of this structure or empty lists in the case of a single node. So if I have a single node that looks like entry, ENT, then this is the structure that we're going to get. We could also, so we could be passed in all sorts of nodes, right? I could be passed in at completely empty nodes, and we're going to call that, or completely empty lists, and we're going to call this an empty tree. All right. So given this structure, so the more typical structure is this could be an empty list, but the more typical structure is that it's going to have a left tree and a right tree, which are both going to be valid binary trees. This is just like in Python, just like the way we do it in Python, except for the fact that we don't have any of the nice guarantees that we had with our assert statement. So we're just sort of taking it on, we're leaving the user to make sure that they're always passing in correct binary trees, because or else this is not going to work. All right, so define entry tree. So we're defining a selector for tree, and we want to be able to return the entry, given that it was built with cons entry, cons left, right. Okay. So how do we get the entry from a tree if it looks like this? This is our tree variable is going to point to something that looks like this. Well, if I want the entry is stored in the first element, so how do I get things out of the first element? Just with car tree. Also, so if you haven't seen the list review that I did, here's a link to it right here. I just made it. Okay, great. So define entry tree, car tree. So this is going to get the first element of a list. This tree is really just a set of pairs, right? A pair with the first element that's going to be an entry, and a second element that's going to be a pair of branches. Right, so if I want the left tree, so we sort of need to think of, okay, well, first I need to get the list of branches out, so we can do that with cutter tree. So now I'm only thinking about this right here, this list of branches, and then since the left entry is going to be the first element of this pair, I can get car of whatever this returns, and it's going to give me the first element of the branches, which is left. All right, so that's that. And conversely, since this is a pair, I can do the exact same thing. So first I'm going to get the list of branches with cutter tree, and then I'm going to get the second element of this pair of branches with cutter again. All right, so it's also important, sort of like scheme is a little weird. You got to think like an onion. It's got layers. I've got to get the second element out of this initial tree in order to get the list of branches, and then in order to get the first element, I'll do car. In order to get the second element, I'll do cutter. Okay, so that's just the beginning. We've just defined our abstract data type. In the next problem, we'll work on actually implementing something with this abstract data type. Great. Thanks for watching.